All right, as you get signed in, okay, I want you to open up the cell transport literacy activity. This is an in-class activity. We're doing it today. You're submitting it at the end of class. It is not homework, okay? You should have no problem getting this done in the time we have remaining. All right, so just kind of manage your time. All right, there are two files, okay? One is the PDF file, and that has the article that you're going to need to read. Okay, the Google Doc has the questions, and that's where you'll type in your answers. Right, when you've got your answers typed in, then you're going to submit it to me. Right, if you have time after that, then you have some time to work on like your cell anatomy lab or something like that. Expectations here, guys, in terms of your answers. I am looking for several sentences for each question. These are not yes or no questions. They are not one or two word answer kind of questions. They are questions that require you to explain and demonstrate to me your understanding. Okay? You cannot demonstrate your understanding with yes or no. Okay? Everyone follow on that. Okay. So the purpose of this activity is twofold. Right? The first purpose of this activity is to work on what we call scientific literacy. Okay, we had a big literacy push in our school division a few years ago. Okay, and these are some of the things that we came up with. Right, we decided that when we were going to kind of go over literacy in science, that we wanted to focus on being able to read a scientific article correctly and get what you needed out of it the first time. Because as a science department, we all agreed that was something we struggled with when we were your age, and especially in university. Okay, in university, you have a lot of reading. Okay, lots and lots of reading. And what I found I ended up doing, and a lot of other people did too, was I was a highlighter, not like an actual one, but a person who did highlight. Okay, and I would find that the first time I read through my textbook, basically everything was highlighted. So did I accomplish anything the first time through? Not much. So I'd go through a second time with a different colored highlighter. I had like 5 different colored highlighters. Okay, so I ended up reading everything like 5 times in order to really discern what was important. Okay, because I wasn't looking at how the articles were structured. I was just reading them like they were a book from start to finish. Okay, and that's not really how you read a scientific article. Right? You need to look for in a scientific article. Bold-faced terms. Okay, you need to look for headings or abstracts that explain to you, here's what the point of this article is. Right? Those are the kind of things we want to look for. Even more important than that, if you know you have to answer questions on a particular article, what should you read first? The questions. I wasn't smart enough to figure that out, unfortunately. Okay, I only figured it out after it was too late. But you should definitely read the questions first. Then you know there's probably some keywords or topics or things like that that you need to be on the lookout for, and you can actually skim over some things that aren't related to those questions. Right? So the first thing we're going to do right now is we are going to look at the questions that we have to answer so that we know what kind of things we're going to be looking for when we read the article. Okay, so the first question we have to answer, it says, compare and contrast the membranes used in reverse osmosis with a cell membrane. Okay, so the whole article is about reverse osmosis and how the process works. Right? But the first question wants to compare the membrane that we use for reverse osmosis, which is artificial, okay, with a natural membrane, the cell membrane. So compare and contrast means find some things that are similar and find some things that are different. Okay, so as soon as I see the word membrane, okay, or something like that, I'm probably going to want to slow down and start concentrating on what that paragraph or sentence or whatever has to say. Okay, so I'm looking for anything about the structure of both membranes. Okay, cell membrane, which we already kind of know about because we talked about it's made of fats. Okay, whereas we haven't talked anything about a reverse osmosis membrane. Okay, second question. What provides the force needed to move water across the membrane in both osmosis and reverse osmosis? Okay, well, we already talked about osmosis. We know it's a passive process. Okay, what moves it across is what? Right, any dissolved solutes. Differences in dissolved solutes on either side is what causes water to move by osmosis. But reverse osmosis is different. Okay, what provides the force that's needed to push the water across the membrane in both processes? Okay, explain why one process requires energy. So that must be reverse osmosis because we know regular osmosis doesn't require any energy. All right, so I'm looking for anything about forces, okay, and pushing and moving water. All right, question 3 says, in a short paragraph, explain and justify if Okay, so you would have to decide whether you think this is true or not. Okay, if you think using reverse osmosis would be an acceptable way to conserve water, what does conserve mean? Save it, use less of it. All right, so the purpose of osmosis, or sorry, reverse osmosis is to purify water. All right, now what they're asking here is, would it be a good way to do that in a place like Okotoks where water conservation is important? Okay, so we're talking about like an entire town's water supply here. Okay, is reverse osmosis a good way to conserve water when we're talking about serving an entire town's water supply needs? Not just drinking water, that's the water that comes out of any faucet in your house. Okay, so you have to think about it in that way. So you're going to say, yes, you think it is, no, you think it isn't, and why. Okay, so that one's going to be probably one of your longer answers. And then in number 4, it was mentioned in the article that reverse osmosis can also be used to ensure impurities are removed from certain products like wine and syrup. Okay? It's a filtration process that can be used. It would take things out like sediment and stuff like that. Okay? Can you think of any reason why purists might disagree with the use of this process? Okay, so purists are people who like to see things done the way they were originally done, because they believe that that original way produces certain things that are inherent to the quality of the product. Okay, so purists would say, like a maple syrup purist, if there's such a thing, okay, would want maple syrup made the original way, not filtered, whatever. Why would they think that? Why would they assume that that would be better or worse or whatever? Okay, everybody follow there. Right, so I'd be looking somewhere in that article for something about wine, syrup, okay, something like that. Maybe there's a paragraph in there that talks about other uses of reverse osmosis. Okay, so now I have a better focused approach to this article. I know what kinds of things I need to look for. Within the article itself, okay, I've highlighted a few things in there, okay, that may be kind of tricky terms. Okay? It is really important to understand all of the terms in an article. Right? If I'm reading a paragraph and I don't understand one of the words in the paragraph, will that interfere with my ability to understand what the paragraph is saying? Absolutely. Okay? When we were going over this, we were reading a bunch of research about the effectiveness of reading. Most people would consider reading at 98% effectiveness to be awesome. Okay? And the guy who was giving this speech to us said, okay, I want to show you what 98% understanding looks like. And he took out a big, thick book, and he tore out 2% of the book. It was like 50 pages. Okay? He said, you read at 98% efficiency. Here's how much of the book you don't understand. And he chucked the papers at us. Okay? Now, most of us would say 98%, pretty darn good. Okay? I'd be happy with 98%. I never got one, so I don't know what it's like, but I'd be happy with it, I'm sure. Okay? But when you see it kind of laid out like that, that's like, one word per page or whatever that I didn't understand. Well, that adds up to several pages by the end of a, 1,200-page book. Right? So we want to make sure we understand all of the words. So if there are no words you understand, or there are some words you don't understand, okay, then I want you to just highlight them. Well, you can do that on there actually, okay, or just write them down on a sheet of paper, and I'll go over them in a few minutes. Okay, I'll go over these ones right now. I'll go over any other ones you have trouble with after a few minutes so you've had a chance to read the article. Okay. All right, so just so we know here, the term desalinization, they kind of have a definition there. Okay, desalinization means to remove the salt from water. So it's the type of purification they would use if they had to use ocean water as their source of drinking water. You would have to desalinate that first. Okay, unprecedented means they've never seen anything like it before. Right, in 2013, okay, we had unprecedented flooding. Okay, we had never seen anything like that flooding before. All right, torrential. Okay, torrential means like it's just unbelievable. It's a wave. It's a wall of water. Okay, it's just coming down in torrents. Okay, that's just huge amounts of water like we've never seen. All right, semi-permeable membrane. Your cell membrane is semi-permeable. That means some things can go right through it, and some things can't. Okay. We also sometimes call it selectively permeable, implying that it can select what kinds of things go through and what kinds of things don't. So your cell membrane is permeable to certain dissolved solutes, calcium, sodium, etc. It's permeable to water, okay, things like that. But other things can't get through. It's not permeable to large protein molecules. Those would have to be engulfed instead. Okay, so anything that can move through by osmosis or active transport, it's permeable to. Anything that has to be engulfed, it's not permeable to, so it's semi-permeable. Okay, osmotic pressure. That's what we talked about a minute ago. Difference in solutes on one side to another creates an osmotic pressure, right? A push of water through the membrane to the side with more salts. That's what osmotic pressure is. Okay. Concentrate means how much of something is dissolved in the material. Okay. And bars of pressure is units, but they're imperial units for pressure. Okay. In the metric system, we use pascals. Okay, pascals is what we use for pressure in, or millimeters of mercury, okay, is another one that we use, okay, in the metric system, but this is how we measure pressure. Okay, and then if you don't know French, voila means there you have it, or there it is, okay. Skeletal fluorosis, okay, I have highlighted here as well. Okay, skeletal fluorosis is a disorder of the bones. Essentially, they become bowed and weak instead of hard. And you can get that if you have too much of certain ions in your water supply and things like that. Okay. And I think, impediment. Okay. If you're impeding something, what are you doing to it? Yeah, you're imposing upon it, you're slowing it down, you're making it difficult, you're putting some sort of barrier in front of it. Okay. Technically, if you go too fast on the road, you get a speeding ticket. You could also get a ticket for going too slow. That would be impeding, because you're slowing the flow of traffic, not allowing it to do what it needs to do because you're going too slow. Okay, you'd be impeding traffic. Okay, WHO and UNICEF. These are two organizations. WHO is the World Health Organization. Okay, they're the ones who impose quarantines and travel bans and things like that. UNICEF is the United Nations International Children's Emergency Fund. It's money for kids. Okay, when I was a kid, you used to carry little orange boxes and you collect the pennies, the UNICEF pennies for kids, and it's a charity basically. But it's the UN decides where that money goes. So if there's a natural disaster somewhere, UNICEF would be one of the organizations making sure there's clean water provided to the people there and things like that. Okay, so that's what UNICEF is. Okay, that's it. So read through the article. I'll give you a few minutes on that, and then I'll take any other questions about terminology, and then you can get started on the questions. All right.